to my today's session on network analysis. Today I am going to discuss some important definition and terminology from the first unit, that is from the AC network analysis. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department in IARE. So first I will discuss about the what is the objective of my today's course. Understand the three-phase systems for star and delta connected system, perform three-phase power calculations and balanced and unbalanced load. And which is the most important objective for my today's class is the present the necessary mathematical background for transient analysis of DC and AC circuit. So DC and AC circuit, and specifically AC circuit state mathematical background we will discuss, and it is for the series and parallel one. Next, what is the outcome? The outcome is the students will try to learn or try to discuss the steady state response and resonance of electrical circuits. Today I will mainly emphasize on the response and the resonance of electrical circuit. So these are the course outcome. So today I am starting my first question number 1. Write the expression for reactance offered by a capacitor. So what is a capacitor? We know capacitor means C is equal to Q by V. Charge per unit potential is called the capacitor. Capacitance is the property of an electrical circuit's element that will store the electrical energy in form of charge. So what is capacitance? So when a capacitor is present in a system, it will offer some capacitance. So the expression of the reactance offered by the capacitors, we know Xc is equal to 1 by omega C is equal to 1 by 2 pi 1 by 2 pi Fc. So what is Xc? Xc is equal to, we can write 1 by 2 pi Fc, where capacitor is equal to epsilon A by D, though this is only for the parallel plate capacitor, and the unit of capacitor, or we can write capacitors is equal to Q by V, and unit is in farad. But what is Xc? Xc is equal to 1 by 2 pi Fc. So what is C? C is the capacitor. What is F? F is the frequency. For India, the frequency is generally 50 Hertz. And what is the unit of Xc? Xc unit is always in ohm. The unit of Xc is always in ohm. And 2 pi F, we can write it by 1 by omega C. Now, and we have to remember, if we have a pure capacitance, if we have a pure capacitance circuit, we have, and the current I is flowing in the capacitor, we know according to the rule, if this is the current I, the voltage across the capacitor will be lagging. This is the Vc, and what is Vc? Vc is nothing but the I into Xc. If this is the voltage, if this is the current, the voltage across the capacitor always lagging by an angle 90 degree. So this is the capacitor. Now similarly, we are coming to our next question. Write the expression for reactance offered by an inductor. So what is an inductor? Inductor we generally draw by this sign. We write it by L. And what is inductor? Inductor is the property of the circuit element which will oppose the rate of change of current. Which will oppose the rate of change of current. And what is XL? XL is equal to, so if we go for this, what is XL? XL is nothing but the omega L, or we can write it 2 pi FL. So what is L? L, the unit of L is inductor, which is depends on the rate of change of voltage, and So voltage is directly proportional to L di by dt. And what is the unit of L? L unit is basically Henry. Again, like the similar case, 2 pi f, for f is equal to frequency, and 2 pi omega is equal to 2 pi f. And what is the unit of XL? The unit of XL or unit of reactance is, again, it is the ohm only. The unit of reactance we can write, it is always in ohm. Now again, if we go for an inductive circuit, so if this is the current, then we can tell the voltage is always 90-degree leading. And what is the voltage? The voltage across the inductor is, we can write it XL into I. What is this? If this is the current, I into XL. So this is the expression of the reactance offered by an inductor. Next, what is phasor? Already we have discussed on phasor. So what is phasor? Phasor is nothing but the pictorial description. We have to remember the word pictorial description. What? Pictorial description of what? Of the magnitude and angle. Of the pictorial description of any quantity's magnitude as well as an angle. So what is the phasor? A phasor is a complex number that represents the amplitude or magnitude, and phase means often sinusoid. If the input is in sinusoidal, then there is a phase angle. So if you are taking one simple example, say we are going for a RL circuit, or we are going for a simple L circuit. So in this L circuit, we know voltage, if we are going, that is the voltage is leading and current is lagging. What is this means? If we are giving on AC voltage is leading and current is lagging by 90 degrees. So what is current? Current will be like this, by an angle pi by 2. So this is a simple AC circuit. Now if we want to draw the phasor of it, what will be the phasor? So we will take, if we take the voltage as our base, so what is the current? Current is lagging. So what is current? Current is lagging in nature. So this is our current. If this is the voltage and this is the current, and what is the current? This is 90 degree. Now we are going for a little complex way, so then you can understand it better. Say we have a RL circuit. As this is an RL circuit and it is a series circuit, already we discussed in our last class about RL, RLC, different type of circuit. Just for simplicity, we are writing this is R and this is XL. So what will happen? Phasor diagram means, here it is a series circuit, means current is fixed all through this. So this is a current I. So we know the current and the voltage drop. Here voltage is V. So what is V? V is not the normal sum, vector sum of VR plus VL. Remember that when this is an AC, there is a current leading, lagging, there is some angle things. We cannot add the two quantities in numerically or in the scalar form. We have to always add the two numbers in the vector form. So as this is a series circuit and the current is fixed through a series circuit, we are taking the current as an base. Now what is VR? Remember that in the resistor, current voltage across the resistor is always in the same phase. Same phase means there is no phase difference. What is the meaning of same phase? Same phase means phase angle or angle is equal to 0 degree. So if there is no phase angle, we can write this is the VR. Now what is the VL? As I told before also, we will remember the civil rule. In capacitor, I is first, so I is leading, V is lagging, and voltage is leading and current is lagging in inductor. So if voltage is leading the current, so leading means leading by 90 degrees. So what is our VL? VL will be in this side. This is the VL. So this is VR. This is VL, which is leading this 90 degrees. So what is V? V is the phasor sum or vector sum of VL and VR. So what is V? The V is, if we add these two, we will get this is our V. So this is called the phasor diagram, and this is the phase angle phi. So this is called the phasor diagram. It is a pictorial description of a complex system which is having the magnitude as an angle as well as an angle. Now we are moving to question number 4. Define the impedance. So already we know in a circuit there is the resistance and reactance. Reactance is, so if we think about the circuit elements, or if we write in a detail the circuit elements of passive elements, we can define in a two part. One is called the resistance, which we write by R. One part is called the reactance, which we write by X. Again, reactance is two part. One is inductance. What is inductance? XL, and is equal to 2 pi F into L. L is the inductor. And another one is the capacitance. What is capacitance? We write by XC, and it is called the 1 by 2 pi FC. Already we have discussed in our previous slide, where C is the capacitor. So this resistance plus reactance together, R and X together, is known as the impedance. The resistance and reactance together is known as the impedance. So now we want to discuss the definition. What is the definition? The impedance of a circuit is the ratio of the phasor voltage and phasor current and measured in ohms. So from the Ohm's law, we know R is equal to V by I. But this is only applicable for the direct current or DC. But what happens if we apply the AC? That time the phasor voltage means V at an angle theta. Phasor means magnitude as well as the angle by I at an angle phi. This is not the R. This is Z. This is Z. And what is the two components of Z? Just we discussed. One is the resistance part R, plus one is the Jx. Jx. Why we are writing Jx? J means J operator, which is similar to the I operator in the mathematics. So what is J? J means 90 degree positive or 90 degree negative. So we discussed in our previous slide the resistance and reactance lead or inductance or capacitance lead or lag the voltage by an angle 90 degree. So what is Z? Z is nothing but the R plus Jx, and the unit of R is ohm, the unit of X is ohm. That's why the unit of Z is ohm. But mathematically the definition is the ratio of the phasor voltage to the phasor current, and we write it by Z. So now we are moving our question number 5. What is the question number 5? Explain the instantaneous power. So one is called the instantaneous power, one is called the complex power. Instantaneous power. as the name suggests, the instant. So the power at any instant. As I draw before, say this is one voltage and this is one current. And at any instant, this is the current. So at any instant, maybe the magnitude is same, but the phase angles are changing at every instant. So this is called the power. What is the instantaneous power then? The instantaneous power is the power at any instant of time. You can see both I am writing V and I. Magnitude is same. Here the angles are changing continuously. The angle between voltage and current is changing continuously. So at any instant, the power is the voltage and current. So we generally write it by small letter. Instantaneous power is generally we write by the small letter, and we are writing it by the small letter P. And what is the voltage? Voltage at that instant into I, current is that instant. So if we want to calculate the total power throughout the time, so we can multiply V into I into dt. So then we can get the energy in a total time, and after that if I divide by t, we can get the power. And again the instantaneous power unit is also what? Instantaneous power means, or we can write the instantaneous power like this: P into dp is equal to, or we can write instantaneous power, sometimes we write like this, dv into di, and we take the integration. Now explain the complex power. There is a small difference between the complex power and the normal power. Complex power is only applicable for AC. Complex power is the product of RMS voltage phasor and the complex conjugate of the RMS current phasor. Complex power doesn't mean the maximum power. This is a one big mistake. The relation between the V RMS into root 2 is equal to V maximum. Similarly, I RMS into root 2 is equal to I maximum. So we are not taking maximum value, because maximum value, it causes at one instant, so it is an instantaneous value, but RMS is the root mean square over a time, so we will always prefer the RMS value. So complex power is the product of the RMS phasor and the complex conjugate of the RMS current phasor. So what is the power? Power is equal to, as I told, if the angle is V theta into I, not I, if the current is I at an angle phi, we will write I star into phi. What is the meaning of I star? I star means complex conjugate. If I tell it little easily, say V value is A plus JB. I am writing it in a rectangular coordinate, and I value is C plus JD. So what is the power? A plus JB voltage and complex conjugate of current means C minus JD. Again, we can write here V theta. If it is I, it should be I of minus phi. Then what is the power? VI theta minus phi. So this is the power. So this is called the complex conjugate. So complex power is the product of RMS voltage phasor and the complex conjugate of RMS current phasor. Now we are moving to our question number 7. Define admittance. It is a very easy question. And what is admittance? We know admittance means reciprocal of impedance. We are writing the admittance by Y. Admittance we write by Y. So what is this? 1 by Z. And what is the unit of Y? Y unit is mho, or sometimes we write by ohm inverse because 1 by ohm. And one more thing, that the admittance has two part, y is equal to G minus JB. What is G? G is called the conductance and is equal to 1 by R. What is B? B is called the susceptance. And what is B? B is equal to 1 by X. So this is the called the admittance of any circuit. So next we are going for the what is the unit of measure of conductance. As I told, conductance means basic definition is reciprocal of resistance. So G is equal to 1 by R. So 1 unit is 100% sure, that is mho, mho or ohm inverse. But what is the conductance? Conductance is the property of a material which will helps to flow the electrons. So what is the definition of resistance? Resistance is the property of any material which will oppose the flow of electrons. But what is conductance? Which allows the flow of conductance. So what is J? J is equal to 1 by R. Then actually R is equal to rho L by A. So it is comes 1 by rho L by A, or sometimes we write it sigma A by L. What is sigma? Sigma is called the conductivity. Rho is known as the resistivity of the medium. Rho is known as the resistivity of the medium. And sigma is known as the conductivity of medium. Okay. So what is the what is the unit of measure? The unit used to measure the specific conductance is Siemens. So this is the unit of the conductance which indicates a measure of electrical conductance. Which is the real part of admittance? As I told, admittance Y is equal to G minus JB. So what is the real part? Real part is conductance. So the real part is conductance. The term impedance Z is introduced which have the same function of resistance, have both magnitude as a phase. Its real part is resistance. So like impedance, its real part is resistance and the imaginary part is reactance. So if we take the reciprocal of Z, Z is equal to R plus JX. So 1 by Y means 1 by R plus JX. So it is coming that G minus JB. What is G? What is G? G is equal to 1 by R and X is B is equal to 1 by X. So what is the real part? Real part is G, which is known as the conductance of the medium. Next we are going for the question number 10. How does the power triangle work in AC circuits? The power triangle shows the relationships between the reactive power, active power and apparent power in an AC circuit. So power is basically three types. One is real power. So if we think about the one RLC circuit, so this is the current. So this is the voltage across the resistance VR. What is this? This is the this is the Vx. I am writing here Vx. Then what is the V? V is the phasor sum of VR and Vx. Already we have discussed many times. So this is the V. Now if I want to, this angle is actually phi. So the angle is actually phi, and we know the resistive voltage and resistive current is always works in the same phase. So if I multiply with I for 3, what will happen? This is called the active power or real power P measured in what is power? VR into I. Now what is VR? VR from the diagram we can see if this is VI, this is the P is equal to what is P? P is equal to VR into I, or we can write V into I, V into I cos phi. So the unit of the real part is what? When we are measuring the power in our anywhere in our AC circuit, we can only measure from a normal wattmeter the real power, or sometimes we call the actual power. So what is the real power? Real power is equal to VI cos phi. So what is our reactive power? Reactive power is, this portion. What is the equation of reactive power? Reactive power we write by R. So it is VI sin phi. VI sin phi is the reactive power. So define what is the real power? Real power is in watts and defines the power consumed by the resistive part of the circuit. You can see from the diagram that it can be measured by the resistive part of the circuit. Another part is the reactive power, which is measured in the reactive part. This is the resistive part. This is in the reactive part of the circuit. And what is the actual power, or we are telling it apparent power? So what is the unit of reactive power? VAR, volt ampere reactive. And what is this? This is called the apparent power and it is written with VA. So one is we got the real power, one is called the reactive power, another one is called the apparent power or total power. Now we are moving to the question number 11. So how to calculate power from a triangle? So this question is, how does the power triangle work? Now how to, same question, just the language is different. So as I told, one is the real power which is in watt. What is even the reactive, that is in the VAR. Another one is the apparent power which is denoted by V into A. And what is the power factor? From here you can see from the first one, what is the power factor? Phi. Phi is equal to, this is S. So what is power factor? Power factor we write by cos phi is equal to P active power by S. So you can see here the power factor is equal to, here we are writing angle is equal to Q, P by S. Now we are moving to the question number 12. Define conductance. So conductance is a unique electrical measurement. We have already discussed the unit. So this is the conductance and we told already. So what is the exact definition of conductance? Conductance is a unique electrical measurement that determines the ability of a battery to transmit current through its internal structure. Conductance is nothing but the property of the material which will allow to flow the electrons. So, or ability to the battery to transmit the current through the internal structure. And what is the unit of the conductance? Conductance we write by G, we have discussed many times, and the unit is siemens. Next, how the RLC circuits behaves for the frequencies above and below the resonant frequency. So what is the meaning of resonance? So resonance means, we know that in an RLC circuit, Z is equal to, what is Z? Z is equal to R square plus XL minus XC square. Now, what will happen if the XL is equal to XC? There may be three cases. XL must be greater than XC, XL is less than XC, and last part is the XL equals to XC. If the inductive reactance is equal to capacitive reactance, they will cancel out each other and Z is equal to R. Though inductance and capacitance present in the circuit, but they opposes each other and Z equals to R. So this is called the, what is this? This is called the resonant frequency. So what will happen if the below the resonant frequency? So two cases. First is the, so for the frequencies below the resonant frequency, the capacitive reactance is more than the inductive reactance. Therefore, the equivalent reactance is equals to the capacitive, and the circuit behaves like a RC circuit. So, what will happen? For the frequencies below the resonant frequency, the capacitive reactance is more than the inductive reactance. Therefore, the equivalent reactance is equal to the capacitive, and the circuits behave like a RC circuits. Then what will have about the above? If it is the above, so the inductive reactance is, so what will happen if this circuit is the above the resonant frequency? The inductive reactance is more than the capacitive reactance. So inductive reactance is more than the capacitive reactance, and then it will behave like an RL circuits. So if the frequency is less than the resonant circuit, it is an RC circuit, and if it is more than the inductive more than the resonant frequency, it will behave like an RL circuit. Now we are moving to the resonant frequency. So as I discussed now, what is the resonant frequency? The frequency at resonance is called the resonant frequency. So the frequency at which the reactance is same is called the frequency where XL is equal to XC is same. So omega L is equal to omega C, or 2 pi FL is equal to 1 by 2 pi FC. This frequency at which the both will be same is known as the resonance frequency. It is always defined as the geometric mean of two half power frequency called the resonance frequency. So resonance frequency can be written as the F1 and F2, where F1 is the lower half power frequency, and what is F2? Upper half power frequency. Now you may ask, what is the meaning of the half power? Actually, in the resonant condition, as the circuit is behaving on like a pure resistive circuit, the power we are getting is maximum, because power is equal to VI cos phi. We have just discussed power is equal to VI cos phi. Now in the resonant condition, it is a pure resistive circuit, and we also discussed in the first slide at the resistance, voltage and current always are in the same phase. What is the meaning of in phase? In phase means the angle is 0 degree. So power is equal to VI cos 0, and cos 0 as the maximum value, that is 1. So what is power? Power is equal to VI. So at the resonant we are getting the maximum power. What is the lower half power frequency? The point at which we will get the half power means P by 2 or VI by 2. So P dashed cos phi 1, we will get the value VI by 2, and P double dashed cos phi 1 phi 2, we will get the upper half means opposite side of the half, because this is an AC circuit. So this is the resonant frequency. We are getting the maximum power. So half means this is our F1. This is our F2. So resonant frequency is equal to square root of F1 and F2. This is the square root of F1 and F2. Now we are moving to the question number 15. Derive the expression for the resonant frequency. So as we have already discussed, XL is equal to XC. So 2 pi FL is equal to 1 by 2 pi FC. So F square is equal to 1 by 4 pi square LC, and resonant frequency is equal to 1 by 2 pi root of LC. What is the unit of this? The unit is in the hertz. Or we can also write omega r or omega 0 is equal to 1 by root of LC. What is the omega? Omega is the angular frequency. So what is omega? Omega is nothing but the angular frequency is equal to 2 pi fr. So moving to the question number 16. Define Q factor. So it is the ratio of the capacitor voltage to capacitor voltage or inductor voltage at resonance to the supply voltage. As we discussed, the voltage is same. So it is the ratio of the inductor voltage at the resonance to the supply voltage. So Q factor, again we can define Q is equal to 2 pi into maximum energy stored, because capacitor or inductor are behaving like an energy storing element, divided by energy dissipated. So maximum energy means 2 pi FL. So we are writing it omega naught L by energy dissipated means R. Or we can write 1 by omega 0 C by R. So it is coming omega 0 L R by C. If we make it equal, we will get 1 by R root of LC. 1 by R. Generally, we use this equation for defining the Q factor. Next is the define the bandwidth. It is defined as the width of the resonant curve up to frequency at which power in the circuit as half of its maximum value. The difference of two half power frequencies is called the bandwidth. As I told before, at the resonant the power is maximum. So at the frequency at which it becomes half, the difference of this is known as the bandwidth of the circuit. Next, we are going for a simple question. An RLC consists of a resistance 1000 ohm and inductance is 100 millihenry and the capacitance is 10 microfarad. What is the Q factor of the circuit? So just now we have discussed that Q factor is equal to 1 by R of root of L by C. So what is R? 1000 ohm. What is L? 100 millihenry. Milli. So it is 10 to the power minus 3. And it is 10 microfarad. So what is the value it is coming? 1 by 10 to the power 3. One by 10 to the power 3 root of 10 to the power 4 means 10 square by 10 to the power 3. So it is coming 0.1. So the Q value is 0.1. It is just check. Henry means inductance and millihenry means it is 10 to the power minus 3. Capacitance is 10 microfarad. So it is 10 to the power minus 6. Next we are moving to the question number 19. Write the characteristics of the series resonance. So as I discussed, for a series RLC circuit, in the resonance condition, power factor is unity. What is power factor? Power factor is cos phi is equal to, and as I know, it is a pure resistive circuit. So the angle between the voltage and current is 0 and cos 0 is 1. So first one is the power factor is unity. What is the impedance of the circuit? Impedance is Z is equal to root of R square plus XL minus XC whole square. Now as XL and X equals to 0, so Z is equal to R. So it is the minimum value. So if it is minimum, obviously Y is equal to 1 by Z. So the admittance is maximum. And what is voltage? Voltage is equal, what is current? Current is equal to V by Z, as Z is minimum. then current will be maximum value. The current is the maximum value. And the last point is the magnitude of the voltage across the inductance and capacitance will be Q times the supply voltage, but they are in the phase opposition. Both magnitude of the voltage of inductance and capacitance will be the same, but they are in the phase opposition. They are just XL and XC both are in the 180 degree apart. Now we are moving to the question number 20. For the circuit shown in the figure, determine the capacitive reactance at resonance. So here you can see that the resistance value is given 50, means 50 ohm. XL value is given as J25. So XL value is 25 ohm and JXC we have to calculate, and we know XL is equal to XC for a resonant condition. So what will be the value of XC? XC value will be 25 ohm only. The XC value will come as 25 ohm only. Now we are moving to the question number 21. Determine the resonant frequency for the circuit below. So what is the formula of the resonant frequency we got? AF is equal to 1 by 2 pi root of LC. So 1 by 2 into 3.14 into 10 microfarad is equal to 10 into 10 to the power minus 6 into 0.5 millihenry. So if you calculate, you will get the value. Maybe it will come 2.25 kilohertz. Question number 22. Write the characteristic of parallel resonance. So a parallel RLC circuits at resonance conditions, admittance is minimum and equal to the conductance, therefore the current is minimum. So as this is a parallel one, so we will make it the voltage is constant and current is changing. So admittance we are getting Y like the impedance. Admittance is minimum and equal to the conductance, because again XL is equal to XC. What does it mean? The reactance is, both reactance are equal and therefore current is minimum. This is one important point. In the case of the series resonant, current is maximum, but here current is equal to V into Y. Current is equal to V into Y. If Y is minimum, current is also minimum. The resonant frequency, the circuit behaves like an inductor. This is again the opposite thing. At below the resonant frequency, the circuit behaves like an inductive circuit, and above it, the circuit behaves like a capacitive circuit. What is the third point? At resonance, the magnitude of the current through the inductance and capacitance will be Q times and supplied by the source, but they are in the phase opposition. Before we are calculating the voltage, but as this is a parallel case, we are calculating for the parallel circuit. So these are the textbooks I followed for my today's class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.